Well, hello there, ladies and gentlemen. So check this out. Today, we did these 4 practice problems, and we had these 2 extra credit problems. And what we were doing is practicing for our quiz that's going to be next week. So, because of an error I made, I forgot to record. And so what I thought I would do for you guys is just do a quick review of the problems, okay? So you can kind of check your work and do all that kind of stuff. So check this out. This is the first one. And you guys said, as a class, you said that you recognize that this number right here and this number right here were the same. So they were equal to 1. And you said, so check this out, they are the same. And here's why I know they're the same. Okay? This isn't how to get the answer, but this is how I know they're the same. If you square this and it's equal to 45, if that's true, if this equals 45, if that equals 45, then 3 root 5 is equal to the square root of 45. Because the square root of 45 is asking, hey, what squared is 45? What number squared is equal to 45? That's what this is asking. This right here is asking, what squared is 45? So, 3 root 5 squared, well, that's equal to 3 times the square root of 5 times the square root of 5. That right there is 9. That is 5. That's 45. So, it's true. This is 3 root 5. Now, let's say you didn't recognize that right away, 3 root 5. What you're going to do is you're going to simplify the square root of 45. So the square root of 45, the way you simplify a square root, man, you need to get a tattoo of this or something so you remember. You take that radicand, the radicand's the number on the inside, and you factor it. So that's 1 times 45, 3 times 15, 4 doesn't go in, 5 does go in 9 times, 6, 7, and 8 do not go in, 9 goes in 5 times. You see how we got that switch? Let's take a look at what the perfect squares are. That's a perfect square, and that's a perfect square. We want to use the set of factors that has the largest perfect square. So, 45 is 5 times 9, so 9 times 5. So check this out. This is saying what squared is 9. We know the answer to that question is 3. There we go. The thing I don't like, because this leads to all sorts of trouble, is this right here. People saying, well, 45 is 3 times 5. I don't like that. And they say, oh, well, there's a pair, and so we take that out. That's a description of a process. That's not really the math. This right here is not very good. That will get you the answer, but it doesn't, in a way, it does that in a way that does not address the mathematical meaning of a square root. Square roots are asking what squared is the radicand. This doesn't really help you with that. It helps you get an answer, but it doesn't address it. And this is also going to lead you to all kinds of trouble. That's extra work, more chances for mistakes. This is the way to do it. Factor the radicand, find the largest perfect square, rewrite it if you need to, and then just look at each of those. This is saying what squared is 9. I know that that's 3. What squared is 5? Well, that's irrational. And there we go. Something divided by itself is 1. Boom, done. Dang, man, that's some hotness right there. All right, let's move on to the next one, shall we? Let's see, we got the square root of 24 plus the square root of quadrant 8 minus 6 root 3. Man, the instructions just said to simplify. So, we're going to simplify 24. The square root of 24. So 24 could be 1 times 24, it could be 2 times 12, it could be 3 times 8, it could be 4 times 6. 5 doesn't go in, 6 does. And you see how we got the switch? That means we are D-O-N-E finished. We found all of them. Let's find the largest square. So we have 2 squares. We have a square number that's 1. 1 is 1 squared. 4 is 2 squared. So we're going to rewrite the square root of 24 to be that. Let's do the same thing with 48. 48 is, so this is where we get into a lot of trouble. This 48 thing is where you're going to get into more trouble than you would with something like 45. Because 48 has so many factors. Turns out 16 times 3 is 48, right? 4 times 12, 6 times 8, 8 times 6. Man, there's a whole bunch of factors. Look, that's a perfect square, but it's not the biggest perfect square. That's the biggest perfect square that is a factor of 48, so that's how we're going to write this. Do you see? And then 3, the square root of 3, that's irrational. We can't simplify that. So this says what squared is 4? That's 2. Square root of 6 is irrational. That's 2 times 3. This number 6 does not have a factor that's a square number, so we can't simplify it. 4 root 3 minus 6 root 3. Now, this is 2 times an irrational number. This is 4 times an irrational number. This is negative 6 times an irrational number. These two irrational numbers are the same. So that's like terms. And we're done. The 3's don't change. The square root of 3 doesn't change. It's like this. What's 4x minus 6x? That's equal to negative 2x. It doesn't matter what x is. It doesn't change with subtraction and addition. The number in front describes how many of them there are. So when you see 4 root 3, what that means is you've got the square root of 3 plus the square root of 3 plus the square root of 3 plus the square root of 3. That's what 4 root 3 means. 4 times the square root of 3 equals that. Negative 6 times the square root of 3, well, that's equal to minus the square root of 3 6 times. Whoa. You see, and when you combine those, that makes 0, that makes 0, that makes 0, that makes 0. We have negative 2 left. You see? Boom, done. Man, that's fancy. Woo! All right, next up, Buttercup. Square root of 75x cubed y to the 4th. So look, we're going to simplify this hotness right here. The thing we're going to do is we're going to take that radicand and we are going to factor it to find the largest square number. So we could do that separately. We could do it like 75. We could do x cubed. We could do y to the 4th. Okay? Now, 75, 25 times 3. Yeah? That's going to be the largest square number that's a factor of 75. X cubed. Well, isn't that the same as x squared times x? The reason we think about that is because we're looking for squares. That's a square. That's a square right there, x squared. And then this is y to the 4th. That's a square. That's y squared squared. That's y to the 4th. Y to the 4th is a perfect square. That's a square number. So let's break this down, shall we? 25 times the square root of 3 times the square root of x squared times the square root of x times the square root of y to the 4th. What squared is 25? 5. What squared is 3? It's irrational. What squared is x squared? X. What squared is x? I don't know. What squared is y to the 4th? That's y squared, because y squared times y squared is y to the 4th. That's why this is true. So, let's put it together. Done. Now, a mistake, people say, oh, that right there, that should be just y, that's a square. It's true, it is a square, but it's not inside a square root. Those two things are totally different. It's like saying that 25 is equal to the square root of 25. That's not true. 25 is, 5 times 5. This is just 5. That's 25. Different. Excuse me. So, done with that one. Next up, Buttercup. Boom, done. Check this out. This is some hotness right here. Your good old buddy, PEMDAS, order of operations. You do anything in a group first. Groups first. Always do the groups first, and then you do an exponent. So we got an exponent, but we got to do the groups first. We can still get the right answer if we were to square this, but I don't think you know how. And it's going to be really complicated if you were to try that. So look, we can simplify the square root of 8. The square root of 8, well, that's 4 times 2, yes? So the square root of 8 would be the square root of 4 times the square root of 2. The square root of 4 is just 2. 3 minus 1. 3 of something minus 1 of the same thing is one of those things. Square root of 2 squared is equal to the square root of 4. And that's saying what squared is 4? And the answer is just 2. D-O-N-E, finished, done. All right, so last one. We'll go ahead and do those bonus questions, shall we? 2 root 8 over 3 root 32. So look, you see these two square root things right here? This is true about square roots. You can separate them like that. They're both inside the square root, so you can separate them. Or if they're already separated, you can put them together. It really depends on what it is that you notice. Here's what I notice. 8 and 32 could be reduced. So I would do this right here. 3 and 2, those are rational numbers, and these are irrational numbers. So I can't reduce that 2 and that 32. Because this is 2, and that's the square root of 32. They're not the same. I can't combine them. So I would do it like this right here. 2/3 times the square root of 8 over 32. Now, I think 8 over 32 is reducible to 1/4, right? Okay, now this is saying what squared is 1, that's saying what squared is 4. You don't have to rewrite it like this if you don't want to, but you can break it apart again. You see, sometimes dealing with it like this is easier, but sometimes dealing with it like this is easier. So this is saying, what squared is 1? Well, that's just 1. 2 times 1 is 2. You don't need to write 1, right? And this is 3 times the square root of 4. Well, the square root of 4 is 2. 3 times 2 is 6. That's 1/3. You have to reduce. Don't leave this. If you do all of this work and you leave it unreduced, it looks really bad. Makes for sad pandas. Reduce. R-E-D-U-C-E. The only time you shouldn't reduce is if you're you know you're going to have to combine like term, or you know you're going to have to do some addition and the other denominators are 6, or in probability. That sometimes makes sense. But otherwise, you need to make sure you reduce. Okay, last one. This is new. We're going to be learning this next week, so it's a preview. Here's the deal. This is a fraction. We want to make sure that fractions have denominators that are rational. The square root of 2 is irrational. So this is something called rationalizing the denominator. I'm not going to give you a lesson on it right here. I'm just going to show you how to do it, okay? So look, the deal is this. The square root of 2 times the square root of 2 is a rational number. That's just 2. It's the same as the square root of 4, right? And we want a rational number. So we want this to become rational. Now, so if I multiply that by the square root of 2, that would be true, but I have to do the same to the bottom and the top, because when you multiply by 1, and that just equals 1, you multiply something by 1, the value does not change. Do you see? So 1 times the square root of 2 is that. So the square root of 2 over 2 is the same as 1 divided by the square root of 2. Those two things are, in fact, 100% equal. So, you're going to be learning about that in the future. If that's totally confusing and you totally misunderstand what's going on right there, that's quite all right. Don't even worry about it. Hey, you guys are wonderful. Hope you have a great weekend. Happy Friday. I'll see you later, alligator.